Hello guys, how are you doing? My name is Ashfaq Ahmed and I work in the field of structural biology and bioinformatics. Today we are going to cover LigPlot and DimPlot. Possibly you already know how to use LigPlot, but I named this video Professional Tutorial. That means I will teach you something new, easy and extra, which will make your life easier, in particular your research life easier, and you can work smartly using LigPlot. What we will cover in this video today, let's have a look. We will cover these 4 steps in today's video: how to take academic license, how to install, how to execute or run, and finally, I will teach you how to connect your LigPlot with pymol. The LigPlot will generate a 2D images like generated by Maestro and PDB-Sum and some other software. So LigPlot normally generates 2D images, but we will connect our LigPlot as an extension to the pymol, and then so easily we will convert that scene, that 2D scene, into a 3D images. So let's start. Okay, so first of all, this is the website of LigPlot. If you don't know how to take it, so just write LigPlot, you will see this kind of thing, and then you need to click here the first result and you will see this thing. So if you don't have LigPlot already installed, then click here academic license. You will see this kind of window. Write your name, actually the first name, the second name, and then department, name of your institute, it means name of your university, address. Address could be anything, just like write the province name and the city name, and that's it. And country. But the most important thing is you have to use email address which has given to you by your university. It means this license do not accept personal emails like Gmail, Hotmail, Yahoo, QQ, or any other server. They only accept educational emails. So from where you will take your educational email? In most of the cases, you must have your educational email. But if you don't have, that is not a big problem. Ask your teacher, ask your colleague, ask your senior, ask someone else to provide you an educational email, and you can use it here and then click here and accept. Once you accept, the email you mentioned here will receive an email, and from that the email will contain a download link, and from there once you click you will download it. Most of the guys making a mistake and they just directly click this download page and they're asking the email and password, so they don't know because you cannot see any registration tab here. So then they are stuck here and they say, oh, how to proceed further. So the first step is that you have to use any educational email, and then on that email you will receive a link, and from that link you can download the program. Once your program is downloaded, you can just unzip and double click And once you double click it, and so you will have this kind of directory, LigPlot, and I have this LigPlus, and it will contain these files. But once again, LigPlot is mainly using Java, or we call it jar files, Java or .jar. So if your computer has a Java installed already, then you will see these kind of files. Let me show you. Sorry again. Uh, okay. So if you don't have Java installed, then you may not see this kind of icon image of Java, like a kind of cup of tea. This is a Java icon image. But you can install Java simply within a matter of 5 minutes. Just type Java installation in your Google and it will automatically fix the operating system you are using, and with a few clicks you will be able to install Java. So once your Java is ready, or if it is already installed in your system, you will see this file in this format, ligplus.jar. Then you can double click and you will see this kind of window. Okay, so let's close it for the first right now. Okay, so we covered how to take academic license, how to install, and then how to run. We will come to step 3. Now, how we can run LigPlot. That is very easy. Suppose I'm using a protein, and the protein is here in the download folder uh, for EXS. So uh, copy or cut this protein into the LigPlot folder. It will be easy. Paste it here. It's here now. So let me open it, like what kind of protein is this, because it will help you in running. So this is the pymol. Let me open this from D, then Lick Plus, then inside the Lick Plus we have 4EXPDB. Click. So now see, this PDB contains two different chains. You assume that it contains two different proteins. This is point one, because I will also teach you protein-protein interaction with LigPlot. Okay, this protein also, and each proteins or each chain contains the ligand. This is your ligand, and for this chain, this is the ligand. Each protein also contains two zinc ions here and two zinc ions here. So this is basically our protein. So let's close it for now. Okay, I closed it. Okay, now let's open Lick Plus. Okay, then file, open PDB file, and browse. In browse, you just select this all files or PDB files. Okay, now you are seeing 4EXS PDB. We paste it in this folder or in this directory a little earlier. So open. Now this is important. You need to understand this window. It has three options: LigPlot, DimPlot, antibody. Today we will cover about LigPlot and DimPlot. LigPlot stands for ligand plotting. It means you can plot all the interactions of ligand present inside the protein. and dim plot stands for dimeric plot. So it means you can plot the interaction between two protein chains or three protein chains or more than two protein chains. It's up to you. Okay. So we will use the same protein because our proteins contains two chain A and B. I showed you already. And here you can see LigPlot takes it from the structure. But when you click here, the LigPlot, it will give you a list of all the ligands or ligands present in this structure. You see that the protein files contains two chains A and B. Each chain contains its own ligand. This is L-captopril, that inhibitor molecule of chain A. This is L-captopril, the inhibitor molecule of chain B. This is zinc 1, this is zinc 2. Okay? Okay, I am taking interest for L-captopril of 301, or in brackets you can see chain A. So click here chain A and now click run. But before running, if you want to include the water molecule normally present in the PDB structures, so you can activate or you can deactivate. Normally they're absent in your modeling RDoc structures. So that's okay. Okay, so another feature I want to tell you, that if you are interested to analyze the interaction of your ligand molecule with some specific residue, let's say from 30 to 40, then in that case the LigPlot program will only check the interaction from 30 to 40. But how you will write, you cannot write like this. You will write like this: 30 space 40 with chain A, like this. For more information, you can see this example 1820A. So 30 to 40A, it means like from the range of 30 to 40 residues of chain A, you can analyze the interactions of that area with the ligand molecule. Okay, now, but here I'm using a default setting, like I'm just interested to find out the interaction of this ligand with all the residues present in chain A. So click run. Now you will see this kind of diagram. You can manage this diagram by moving, click your left mouse button, and now you can move on. Okay, wait. Okay, so if you see these kind of eyelashes, then you can see you can move each and everything. You can set your scene as per your need. Now, these are the residues. This is histidine 120 of chain A, aspartic acid 223 of chain A, but this aspartic acid is not interacting directly to the ligand. This is the ligand. Can you see here? This is the ligand, and I will also use this picture in the thumbnail, so I'm also making it a bit more beautiful. Okay, I think this one is fine. So this is your ligand. The ligand is directly interacting to the two, this is the sulfur atom. The blue one, always in biology, these are N's, and the red one are oxygen. In pymol, the or in many of the visualizer, carbon is mentioned by a gray color, which is a default color, but LigPlot mention it with black color. You can also change it to gray. I will teach you. Okay, so this is the sulfur atom of the your ligand, which is interacting. You can see with the zinc ion 1 and the zinc ion 2. And if you feel this zinc 302 is far away, so you can move it here closer with the left mouse button. Now, if you think that this is beautiful, this is what I'm looking for, and then you can export this image. Click here, File, and write PS. Then in the PS document can be exported into the PNG. The PS is actually the PostScript files, and you can name it, let's say 123. This is the PS name. Okay, save. Then they will ask you for portrait or landscape and whatever, and I say okay, landscape is okay. And okay, now this is uh, it has been generated. Now another thing, the point 4, how you will import, how you will connect pymol directly with this scene, and how you will teach pymol only to pick this scene which you are looking. So for that, the first part is that your pymol must be installed on your system. If it is installed like I have, let me show you. This is my pymol. So you can see it's a pymol. Okay. Now what you need to do, just right click on the pymol, then come here, show more options, and then come here, properties. In the properties, you can see the location. Location, in my computer, I kept this icon on the desktop. In your case, if it is not on the desktop, doesn't matter. You can go there and right click on the launching icon of the pymol. So just click here, location, copy this address, Control C, copy it. Now, what you need to do, come back to the this window and click edit. Once you click edit, you can see this one, program paths. Now it's a pymol executable. Pymol executable. Then you have to paste it here, Control V. And then pymol.exe. You have to mention pymol.exe. But be careful, just look here, okay? Save. Okay, look here. This is exe file. When we were copying this, so it copies this information, but it is not copying this information, pymol.exe. Exe means executable. So this is executable file. So you will copy this information, paste, and then you will write this information with the same caps lock or no caps lock, whatever you are seeing here in your computer, just copy it here. And upon saving, you will see this kind of thing. But if you want to see them in the resmol, so just type, do the same thing with the resmol if it is installed on your system, and save it here. Okay. Now if you click the edit again, so here you can see the sizes. For example, if you want to increase the plot title, so you can change this number. If you are not feasible with this Time New Roman font you are seeing here. You can change if you are not good with the this font of the residues name, blah blah blah. So you can change many things. If you want to change these lines, the weight and the lengths of these things and these things, so you can change the sizes of these balls, each and everything, and then save it. Again, this was the sizes parameter. Now these are the color parameters. If you want to, the label should be non-ligand residue should be olive green, black, blah blah, and all these things. So you can change these color settings from here, and program paths I already taught you. And here is the runtime parameters. Okay, this is important. At times, I receive many questions from my students, and they're asking me that, sir, I check the interaction of ligand with this program and this program and this program. And I say, okay, what is the question? So they're asking me that these two programs are picking a hydrogen bond between this residue and the ligand. But LigPlot is not picking any hydrogen bond. What is the reason? So the reason is that if you are using a default setting, so the LigPlot will make it a hydrogen bond if the distance between the donor and acceptor is 3.35 angstrom, and if the maximum HA distance should be 2.7 angstrom. You can change it to maybe the other programs they are using 3. So if they are using 3 and LigPlot is using 2.7, and if those two atoms are away 2.9, so according to LigPlot there will be no interaction, but according to that other program there will be interaction. So in that case, I suggest you to tweak this number or to tweak these values. And if you don't know what to write here, if you want, otherwise the default is fairly enough, and they are fairly sufficient. But still, if you want to change it, so you can change it very easily. Just take search on the Google what should be this distance, and they will tell you the minimum range and the maximum range from the paper, and then you can manage whatever you want to do, and then save as default. But I'm not saving it as a default, it's already there saved. Okay, so these were the 4 things I mentioned to you. Okay, once you mentioned, this is the very interesting thing. Once you mention your pymol, okay, not here, it's here in program paths. Once you mention the pymol executable here, now let's see the magic. Click here. Your this button will be turned on like I have. So now I'm going to check the magic. Okay, click here, pymol. Okay, possibly I made some mistake, so let me do it again. Pymol, possibly runtime parameters, program paths, pymol.exe. Let me check it again. I think it should be like this, /, or we have to restart this program again. If it doesn't work this time again, let me restart it, this program. I'm going to pause this and will show you how I solve this problem. Okay, we'll come back. In my computer, the exe path is by default. So what I did, I just removed the .exe, and it should be backward slash. You can see I change it backward slash again and remove the pymol exe, and it worked. But in your case, you first try to mention .exe, but if it doesn't work, then you need to remove the exe. That will not be a big problem. Okay. Now, why it is important? Let's see the magic. Oh my God, it's doing the same thing. It means some problems with my. Okay, let me write the .exe again. .exe, save, then pymol. Come on, let me restart again, possibly. Okay. Okay, I think there is some problem with my system. Let me show you my path. I remove the exe and now click it here. Now it worked. But if I close it, maybe it may not work. So I think there's some problem with my path. Okay, now check here. Each and everything is here, only those residues. So very easily they managed to do this for me. Okay. Now, if you don't want to these labels, so you can hide label, H hide label. Okay, no labels, and then show labels again. Now if you want to display this with the white background, let me do it for you. Okay, now it's a white background. Now if you are seeing this thing, like these balls are very high, so I have already pretty much great tutorial on how to render high quality images. So I will drop those links also in the description section of this video. If you haven't watched those tutorials, I will highly recommend to watch those tutorials of, I think, 20 minutes. So you will be able to use pymol efficiently. Okay, so sits here. Now I'm going to change the sphere scale, let's say zero point 0.6. Now you are seeing the spheres are a bit smaller. Okay. Now, so this kind of images you can create, you can do whatever you can create using the pymol. You can also turn on and turn off many things, just like if you are not, if you don't want to see the ligand, just click here. This ligand extra padding will be off now. This is the ligand, but it was padded just extra. And these are the different protein residues. These are their interactions. These are the metal interaction possibly, but okay, these are the hydrogen bonds, but uh, okay. So these are the different things, but I also see some uh, strange behavior of my computer. So in your computer, you may be able to see these lines. And if you don't see that, that's also fine. You can use the distance command and generate these lines. So let me take this figure with the high resolution 24 2D. Let me tell you again, you can make this figure more beautiful, and for that I'm not going to make this video much more longer. So that's why I would suggest to watch those other 2 or 3 videos, or one video. I don't remember exactly, but I will drop the links in the description section. Okay, just hit it enter, and now we have this figure. So let me generate it like PNG, and I will also name it 456.png. Figure is generated, and now I can close this window. Okay, now if you this was all about the replace. No, okay, protein, and this one is my protein is here for EXS. Okay, Now this was all about the dim plot. Now we are going lick plot. I'm sorry. Now we are going to calculate for the dim plot. So for the dim plot, I will just teach you something. For example, we have the same protein. I will use the same protein which I'm using it. So let me open that protein in pymol. Okay. Now if you color by chain, now two different chains you can see. So let's say we are interested in to find out the interaction of this protein. So how we can do? We have two chains. This one is the green one and this one is the cyan one. So we will select this portion and we will also select the whole protein. Let's say this one. So for this one, I will click here and we'll see randomly this is almost 151. And then this for portion, I will say this is 170. I will say, okay, 151 to 170. Come to the lick plot, sorry, the dim plot. This was the lick plot. Now, dim plot 151 dash to 170 and chain B. If you see here, this cyan is chain B and this one is chain A. So they are 271 and starting from 34. So I will do this one. This is domain 1 and starting from let's say 40 to 271 space A. You can include water, that's okay. Uh, if you want to see the same order, so click checked it, otherwise leave it. Okay, now it's running. Now you can see it says that only three amino acid from chain A, histidine, GLN or glutamine 147 and threonine 162 from chain A is interacting with threonine 162, alanine 164 and 152. I forgot to mention this value 2.45 is the distance between the Ne2 and OE2 which are interacting atoms, and this distance is in angstrom. These are actually the hydrophobic interactions observed in this protein-protein interaction. So once again, if you are only interested in this figure, just click pymol and it didn't work this time. So we will click again because I told you some issue with my system. Um, I will need to fix it, but let me try a few more times and okay, now you can see. Now here they are telling you like what you can turn on the display setting. Okay, so they are telling you which atom is from chain A, what residues are from chain A and what residues are from chain B. You can do also another thing, just let's play smartly. How, what to do? In the same pymol window, just open a real protein. Now, can you see? Let me make this background white. Now, check here. You can hide the label. Wait, hide labels. Okay. And you can hide all the other things. I mean, you can hide cartoon or whatever. So, and finally, you will be able to generate a very beautiful image or a very beautiful figure for this protein-protein interaction. And let me let me make some settings. Set cartoon oval length. Okay. You can also provide some extra surface, but I'm not going to make this video much more longer. So still we are going with 35 minutes. Okay. So let me generate this figure again. Okay. So until this figure is generated, I will talk to you briefly. If you watch those other two videos, I will share links in the description section and it will help you, let's say PNG 789.png. Okay, now let me close it and can we watch that? Okay, now we generated this figure already. Okay, and we have generated this figure. Okay, and now we have generated this 1 2 3 PS, this one. Okay, so if you don't know how to save this PS figure, the PS figure can easily be saved to how to say, it can easily be saved to the PDF. There are a lot of programs available, but you can search for yourself. You can write the code here. Right now, I don't remember the exact code, but you can simply change it to the PDF or PNG or whatever you want to change. So this was all about LigPlot and DemPlot, and I also taught you how can you connect your DemPlot or LigPlot, particularly with pymol. Also, you can connect it with ResMol, and this way you will be able to quickly generate your 2D scene into your 3D scene. Okay, if you are a Navy user or a beginner in bioinformatics, so that's why I suggest you to watch that other videos where I professionally taught you how to generate outstanding images using pymol. So taking some information from that videos, you can make these pymol scenes very beautiful and very elegant. So that was all for today. If you're liking my channel, please subscribe. And just a kind of complaint, I'm seeing it on my YouTube editor or YouTube studio. I'm watching that almost if 100 people are watching my videos, 25 are my subscribers, 75s are not. That's okay. I will still continue making such kind of videos, but I would be more happy if you click subscription. It's free. I'm not asking for any money because my channel is not so big to announce a premium membership. Once I become able, then I will do that. And maybe I will keep some specific members for teaching, or at least I will be sure that they are paying me response. Okay, so for now, thank you so much. If you have any question, please ask in the comment section. I'm trying my best to comment each and every to answer each and every comment you posted there. Still, if I miss someone, so I'm sorry, but I'm trying my best to answer each and every comment you are posting. Thank you so much. Bye bye.